Let's practice a couple of example ellipse problems. So we can go from the equation to the geometry with something like this. Here's an algebraic equation, and I could ask you to describe the foci, the vertices, the co-vertices, the center, and if you had all these, you could pretty much graph the thing. The most important, everything's going to be based off the center. And so we're going to get this in standard form, read off the center, and get everything else relative to the center. So let's see. We need to gather the x's. This is going to be a perfect square. We need to gather the y's. Now, you could do that in 2 steps, gathering all the y's and then factoring out this 10 in front of this. Or if you're trying to be efficient, you could say 10 times y squared minus 8y times 10. Can you see if you distributed that, you get into 8y, plus blank, that's going to be my perfect square, equals, and I'm going to move that -1 over to the right. I have to keep the equation equal, so whatever's in that, I'm going to put over there. Whatever this ends up being on the left, I'm going to put it over to the right. Here, to make a perfect square, 2 divided by 2 is 1, squared is 1. -8 divided by 2 is -4, squared is 16. How much did I really increase the left side by, though? That's 160. So I'm going to increase this by 1 and 160. That keeps the equation equal. This is a perfect square, a perfect x plus 1 square. If you distribute, you get those 3 terms. This is 10 times a perfect y minus 4 squared, and you can distribute and check that. 160 plus 1 minus 1 is still 160. To get it in standard form, you need a 1 here, so we'll divide everything by 160. So x plus 1 divided by, x plus 1 squared divided by 160. Dividing this by 160, 10 cancels, so you get y minus 4 squared divided by 16. Okay, so what do you get out of this? Well, you can see here that the center, right, the center is going to be at -1, 4. And the larger of these 2 squares, that's going to correspond to A, or the direction of the major axis. So the major axis is going to go in the x direction. Like if you were graphing this, you just know, okay, this is larger, so you're going that direction. A is going to be the square root of 160. That comes out to something like 12.65, okay? B is going to be 4, the square root of 16. C is going to be the square root of a squared minus b squared, which is the square root of 144, or 12. Okay, so how can I get all of these other things if I know A, B, and C? Well, the foci are the first on the list. That is right and left from that. So the foci are -1 plus or minus 12, 4, going right or left. The vertices are -1 plus or minus 12.65. And the co-vertices are -1, 4, going up and down 4. So notice the co-vertices, for instance, are -1, 0, and -1, 8. I've taken the liberty of graphing that on Desmos. I just put in that initial equation, and this is what I've got. You can see there's the center, up, down 4, right, left 12, right, left 12.65, and that's what we have. The other direction is geometry to equations. Let's say I knew something physical about this shape. So I know the center is out here. The focus is even farther out here, and the vertex is farthest still out here. Well, notice I know A is 3, distance from the center to the vertex. The focus is root 5, right? So I'm almost there, and remember, A squared is supposed to equal B squared plus C squared here. So I've got 9 equals 5, B squared plus 5. So what's that give me? Subtracting the 5. b squared equals 4, so b is 2. So what's that give me my equation? X minus 4, the center is really that key thing, y minus nothing at all, because it's minus 0, over something equals 1. This is the major axis is right and left again, so this is over a squared. That's over 3 squared or 9. This is over b squared, 2 squared, and that's the equation.